Okay, welcome everyone to the top 10 reasons why you'll like Windows Server 2016. I'm John Saville. I'm a principal architect down in the Dallas Technology Center. I had Love originally, but maybe it's the British Reserve. They felt that was a bit too strong and people aren't that passionate about software, so they kind of changed it to like. My goal for this is not to go super deep into any one feature, but my job is really just to talk to customers, find out what interests them. And I found in all those different conversations that these 10 features have really been the key things for all of those customers. So that's what I want to really dive into today. I love we have this very intimate room. It's great that I can sort of get that feedback as I'm presenting. I cannot see you at all, so we'll have to kind of save questions at the end. So this is the agenda. I don't want to spoil the excitement what the top 10 are. These are not in any order. For those that know me, Hyper-V would probably have been first. But what I did find that was very exciting is if you go down to the show floor, they actually have a Nano Server comic. I've never seen a Windows feature of a comic before, but there's actually a Nano Man, a super-powered Nano Man with his container assistant. So you should definitely go and check that out. Now, when I'm talking about these 10 features, I want you to keep in mind there are really two different personas of Windows Server 2016. I can think about the persona that is the host operating system. And we may not always have control of that host operating system. We could be in a cloud environment, so I may not be able to leverage Server 2016 as the actual host. But then there's Server 2016 actually as the guest, and that we have a lot more control over. And as I talk about these features, I'll really try and point out, well, when I can use them in the different types of scenario to give you as much opportunity as possible to take advantage of this stuff. So let's kick off Nano Server and configuration levels, because things have changed in Windows Server 2016. Those that have been in the industry for a while probably remember Windows Server 2008 introduced Server Core. It was this cut-down version of the operating system, and I had to pick it at installation time. I couldn't change it post-install. But it was designed to be the future platform for Windows Server, but there were some problems. I couldn't manage it remotely, but it got better and better. Then in Windows Server 2012, we had these flexible configuration levels. I could add and remove the management tools, the graphical interface, even a desktop experience for remote desktop session host environments. So where are we with 2016? So 2016, it's been brought back to 3 real configuration levels. You have Windows Server with desktop experience. This is really aimed at remote desktop session hosts. The goal is not for you to use this for any other scenario. It has the graphical shell, it has the management tools, it has the core operating system itself, and it has desktop experience. That gives us the client-like experience for when the users use it as an RDSH target. Then we have Server Core. This is probably going to be the goal for most of the sort of Windows Server operating roles, for most of the application servers you're going to run. Now, there's this brand new Nano Server thing. I'd ask for a show of hands, but I wouldn't have a clue if you were raising your hand or not. If you've played with Windows 10, you've probably seen there's this idea of a current branch and a long-term servicing branch. Current branch gets updated probably every 6 months, new features, new capabilities. Whereas the long-term servicing branch follows the standard 5-year support and 5 years extended. This is also applying to Windows Server. Now, Windows Server with desktop experience and Server Core are following the long-term servicing branch. You will get a version every 2-3 years. It will be supported to 5+5. Nano Server is using the current branch for business model. It's going to get updated and refreshed every 6 months. So when I get on the Nano Server train, I'm going to be refreshing that build every 6 months. And that may seem scary at first, but you've probably heard of this pets and cattle thing, that we're used to pets as servers. We name them. We care for them. If they're sick, we nurture them back to health. The direction is more they're cattle. If they're sick, you shoot the thing, and you stand up a new one in its place. Nano Server embodies that completely. In fact, Nano Server isn't cattle, it's chickens. And we don't even bother giving them any attention. We're just going to spin these things up and down very, very rapidly. Now, before I carry on, I'm going to actually try and do a lot of demos during this session. So I want to jump over onto one of my boxes. And I have a shell virtual machine. And what I'm going to do is just quickly kick off a bit of PowerShell. And what this is going to do is going to build me a new Nano Server image. This is going to create me a VHD file, and it's going to put in a certain number of features. It's going to join it to the domain. And I'm just going to let that run in the background. So while that's going on, it's a Nano Server. It's tiny. It's really designed for these new born-in-the-cloud applications. It's designed to run my cloud fabric, so my Hyper-V boxes, my scale-out file servers. Things like Active Directory domain controllers do not run on it today. But very much the future is Nano Server. This will be the platform that everything will be built on in the future. It's not installed in a traditional manner. If you've played around with Windows Server 2016, obviously the trial is available to you now. If you put in that CD, you will not see a Nano Server option. So where did Nano go? Because Nano is not installed in the traditional manner. If I actually go and look at the media on a particular box, so this is the trial media, what you'll see is there is a Nano Server folder. In that folder is a WIM file, and notice the size of it, 168 megs. And then there's a bunch of packages. Now, these are the various features and roles that are supported on Nano Server. So unlike Windows Server that has just everything on it already, and I just enable things, Nano Server, the base image, doesn't have any of those features. It's just the raw operating system. And so what I'm doing in my command is I'm actually telling it, hey, look, I want to build myself a new VHD. I want to add in Defender. I want to add in the storage capabilities. I want to enable remote management. I want to enable desired state configuration. So I'm taking that base image, I'm adding in the various packages I want, and that's going to spit out a custom VHD for me that I can then use for a virtual machine. I could boot from a physical device. So it's a very different thing than we're used to. And now that's built. That's finished that off. But this is how we're going to light up these new scenarios. And it works very tightly with containers, and I'm going to talk about that in a second. But if I want to build things super fast, and I want super high density, this is what Nano Server is going to give me. So just to give you an example of what this kind of looks like. So what this has done is it's created a new VHD file. So if I jump over to that build directory, if it'll let me. There we go. There's that. So it spat out this VHD. I'm just going to move it over to the virtual hard disk folder of this particular shell virtual machine I've got pre-created. And now if I actually go and add that disk to the virtual machine, so this is the first time it's seen it. As part of the configuration, I told it I want it to be part of a domain, but it's not been run yet. This is going to be the first time this thing has ever actually executed. Let's go to my VMs folder. Go and find my Nano VM, hard drive, and there it is. So I've added that. Now, if you've ever done a sysprep on a machine and the first time you start it up, it takes a while. It has to go through the specialization phase. So I'm going to click Start. So it's the first time this image has ever actually run. It's going through that specialization process, and I actually injected in a custom unattend as well, and it's ready. That's Nano Server. So I create these images super fast, and it's a member of my domain. As part of that, I added it to my domain. Now, if you've seen Server Core, this is even thinner than Server Core. There is no command line interface to this. You have this kind of emergency console, but I can't open up a command prompt. I can't open up PowerShell. This is designed to, yeah, I can fix a few firewall rules. Yeah, I could fix WinRM. But the goal is remote management. There is no local management of this. I manage this through Server Manager. I manage this through MMC. I can even manage it through server management tools. Now, this is part of Azure. So if I go into Azure, I've got this Nano VM. And if I select this, now I just rebuilt this thing, so it's going to have to go and work stuff out. I click Manage As to give it a credential that I actually want to use. And I could save that in Azure if I wanted to, but I didn't in this case. Click OK. And what I have is on premises, you have a Server Management Tools gateway. So this is not Azure talking directly to every single machine I want to manage with this. There's a gateway that actually connects outbound to Azure. I'm not opening up ports from Azure to my data center. I'm actually connecting inbound. OK, that's interesting. Imagine this was working fantastically. But actually, through the gateway, connects outbound and enables this communication. And so what normally I would get, and it's not going to on this particular day, is I would be able to see the processes, the performance. I could open up Device Manager, Event Viewer. All of those different aspects would be available to me. And this is kind of the future here. Now, this isn't just for Nano. I could use this for Server Core. I could use it for Server with Desktop Experience. And it's even going to be backported to things like 2012 R2. So I'm going to have this ability for these graphical tools through a web browser. Now, another interesting thing that's kind of happening is cumulative updates. The days where I get distinct separate patches for every single little thing have gone. Windows Server 2016 Lite, Windows 10 has moved to cumulative updates. The challenge in the past was, let's say Microsoft released 30 different patches. Each company looks at those patches and says, well, I want these 5. Another company says, I want these 5. And every month, they pick a different selection from what's available. So over time, that extrapolates out to kind of an infinite number of variations, which Microsoft cannot test. That's why you see these problems out in the wild. It's like, well, why did Microsoft not test that? Well, Microsoft tests every patch installed. That's all they can do. Any other matrix is not feasible. So now with the cumulative updates, you will get all the patches. Once a month, you're going to get a cumulative update that has all the various types of patch available. And it is cumulative. It's going to contain all the things from the previous months. So if I do a brand new install, I install a latest cumulative update, and I'm up to date. So it's going to make things a lot simpler in terms of a patching strategy for an environment. There will still be out-of-bound security updates. If there's some huge issue, they're not going to wait a month because, hey, we just released something yesterday. They're going to release that on an as-needed basis. But all other types of update will come out as part of this cumulative. So containers, as my kind of numbered, this fits very well with Nano Server. I think you're going to see these go very much hand in hand in most environments. And as an IT person, I find this challenging at first to get my head around what is a container. And I think about a few different things this helps with. I remember my days when I was in consulting. I would work with the dev teams, and they would give me their custom code they've written and said, OK, you need to get this deployed. It needs this particular .NET version or this version of Java, and these other little things. Install all that, and then run these commands. And I would do that, and it would completely fail. And you go back to the developers. They say, we'll try this. In the end, they would just log onto the box. They would install their dev tools, and it would magically start working. Because they really had no idea of the dependencies of the application. There wasn't a prescriptive way to take what they did and move it into a production environment. Also, density. How do we handle separate applications today? We create a VM. Every app gets its own VM for a number of reasons. I want to do resource constraints. This app is allowed to use this amount of memory and this amount of CPU and this amount of network. And I don't trust that app over there. It looks shifty. So I want an isolated space. I don't want that app to be able to do anything to my app. But my density is hideous then. Every app has an entire virtual machine, an entire OS instance just for that. So Containers solves this. What Containers does is it enables the developer to develop in a container environment. Each dependency is its own layer. And the idea of layers and images can be confusing at first. I think of really, at the base level, an image in containers is a virtual file system. It contains the particular files and registry that are applicable to that particular component. It could be IIS, it could be ASP.NET, it could be the app itself. And you layer all these different images together to create the overall container solution. So this gives me very fast deployment. I get very high density. Each container instance runs in a user mode isolated sandbox. So they can't see each other, but they are sharing an OS instance. So I want to spin up a new container. There's an existing container host. It just deploys to it. It's up and running in a second. These really fit well in microservices. A great example someone told me is think about a stock application. Someone does a query to this stock application and says, show me the history of these 10 stocks. Well, with containers, it would spin up 10 separate container instances. Each one goes and checks a particular stock, gets the information, and reports it back. And then it destroys itself. So these things constantly create, delete. It's a massive ability to scale. And high density because I'm sharing OS instances. Now, you've probably heard the term Docker. Docker is kind of a standard. Docker is the standard around a repository, around management tools, and Windows Server 2016 Containers uses that. In the early technical previews, it used Docker, and it had its own kind of management stack. This didn't really work very well because they couldn't see each other. If I created a container in the PowerShell stack, I couldn't see it with Docker, and vice versa. So they actually got rid of their own management stack. It's all Docker now. There are still PowerShell commandlets, but all they do is they call the Docker REST API. So Docker is the management engine for containers. And to kind of stress this, I mean, this is what a container is. I have an application, which is an image. It has dependencies on another Docker image, which has a dependency on a certain operating system. So in a single operating system instance, I could have 5 different container applications. I could have 20, 50, 100. Some of them might use the same images as a dependency. Others need different versions. So I can have 20 different versions of the same middleware layer. It doesn't matter. They're isolated from each other. So if I'm the application, I'm looking down on the file system. It's unioned. I would see the files in my applications image. I would see the files in my dependency. I would see the files in the operating system. All the layers are read-only except my application. So I can't corrupt or cause damage if someone else is using the same image as a dependency. It's isolated from there. And to just give you a super fast idea of kind of what a container looks like, I'm just going to jump over to my container host. And what I've got here is I'm trying to access a web page. And let me just do a refresh. This is ruining my fun right now. It's not available yet. This is from a cache, but that web page isn't available. So it's not there. If I jump over to my virtual machine, this is my container box. And what I have in here is a Docker file. Now, these are super simple. It's just a list of commands that I want to do. So in this particular Docker file, I'm basing this on the IIS image. Now, the IIS image relies on the Windows OS image. I'm deleting the default start page. Now, that cannot delete things, remember, from that image. It's read-only. But what it's doing is it's kind of putting a delete command at my applications view to say, well, don't see that file. It's not really there anymore. And then I'm saying, well, copy everything from this folder into this folder. So I'm basically replacing what the website content is. So then in Docker, right now, if I looked at all the images, I can see I've got an IIS image, I've got a Windows Server Core image, and I've got a Nano Server image. So I'm going to do Docker build. I'm going to build that Docker file. So what that has now done is it's created a new image called demo site. You see how fast that was? That's just taken those commands and executed to create me my own Docker image. And now I'm going to run it. Now, when I'm running it, one of the interesting things about containers is it uses the VM switch. It uses the Hyper-V networking. And what I've got by default is an internal switch. Now, an internal switch means the VMs on the same host can see each other, and it can see the host. A new feature in Windows Server 2016 is NAT is now just built into the VM switch. So even though this is an internal switch, because NAT is now enabled, they can still get to the outside world. But I want to be able to get to the container. So what I have as part of my command is I've got a port forward. So I'm telling it, well, port 8080 on the IP address of my container host is going to forward to port 80 inside this particular container. So if I run this, this is going to start that container instance. So now, if I go and refresh, so I'm going to my container host IP, port 8080, and refresh, there's me and my son on Rock and Roller Roller Coaster in Disney World. He was quite scared. And just to show what an awful father I am, there's a picture of him on another ride, also really scared. I'll be healing from Child Protective Services anytime, I'm sure. And then I could just delete that container, and my son would encourage me to do that rapidly. So that's containers, and that's great. It's a user mode isolation. Each container cannot see other containers from a user mode level. But what about kernel? They're still sharing a kernel. So what's happened in Windows Server 2016 is I have two options. I have Windows containers, user mode isolation, but I have Hyper-V containers as well. With Hyper-V containers, it spins up an automatic virtual machine. I do not see this. If I look in Hyper-V Manager, I will not see it. If I go and poke around the system, I'll see a VM worker process for it, sure. But this is automatically managed. And what it's doing is it's spinning up this automatically managed virtual machine. It's using Nano Server, so it's super small. It also uses cloning to make it even faster to deploy these things. And then it runs the container in that automatically managed VM. The container is no different. I don't do anything different as a developer. There is nothing different building the container. It's a deployment mode switch. I tell it, do I want user mode isolation, or do I want kernel mode isolation? Nothing else different. So if I'm in a private cloud environment, if I trust all the other tenants, then I can just use Windows containers. If maybe I have some things that are a bit more suspect, maybe I'm a multi-tenant environment, then maybe I want the extra level of isolation, I use Hyper-V containers. But there's nothing different I have to do in the container image itself. It's just a deployment choice. So storage. It's actually kind of interesting what they've done here. So there's two big features that I focus on. Storage Spaces Direct and Storage Replica. Now, there is a change in Windows Server 2016. There is now a difference in functionality between standard and data center. I'm sure you've heard this already. But now certain features are data center SKU only. And these are some of them. The others is software-defined networking v2 and shielded VMs. That's really the things. Nothing was removed from standard from 2012 R2 to 2016. It's only certain new features really aimed at the enterprise or in data center only. Now, these are not the only two features. ReFS got some big improvements around performance. I have multi-tiered different performance levels, like a mix resiliency levels. ReFS also does this really cool thing now where if I'm expanding a VHDX file, it's instant. It doesn't have to go and zero the blocks out anymore. Now ReFS won't let me access blocks that I've not initialized. If I try and merge checkpoints in together, it's instant. It just does metadata updates to point to different blocks. It doesn't actually move any blocks anymore, so it's super fast. But I want to focus on these two, Storage Spaces Direct and Storage Replica. Storage Spaces Direct really builds on that hyper-converged idea, where many of us have SANs. We have NAS devices, and that's great. But if you look at more and more of the new sort of environments and the appliances, they have local storage. And I want to be able to take advantage of that local storage. And in the past, I couldn't in a cluster. There was no good way to use any kind of local storage in a clustered environment. What Storage Spaces Direct does is it enables me to take the local disks in the nodes in a cluster, and it aggregates them up. It uses resiliency. Each node is a fault domain. So it replicates data sort of 3 times, just like Azure. So data is spread over 3 different nodes on 3 different disks. So if a disk goes down, I've not lost anything. If a node goes down, I've not lost anything. It's using SMB3 as the transport to do that replication between the nodes. And of course, SMB3 can use things like RDMA, so very, very high performance for that replication. The cluster itself sees it as a cluster shared volume. I can use it for my Hyper-V VMs. I can use it as a scan-out file server. This is the one instance we use ReFS. So ReFS got a lot of improvements in 2016. In my view, I still focus on NTFS, except for Storage Spaces Direct. For Storage Spaces Direct, I use ReFS because of the mixed resiliency. As data initially comes in, it uses a mirrored resiliency for the highest performance. Longer term storage, it can move it to a parity-based resiliency. And it auto does that tiering. If it has NVMe, it uses the highest performing for cache purposes. So it does all of that for me. It has the resiliency across the nodes. So let's just try and do another demo. I'll take this down. I feel really guilty. I haven't put this up in the first. Really guilty is probably an exaggeration. Let's find, I have a 4-node cluster. So in this cluster, each of the different virtual machines has sort of 2 data disks attached to it. So I have 4 nodes. Each VM, I have 2 data drives. So within that virtual machine, I'm going to just go to the first node. You create a cluster as normal. You enable cluster storage spaces direct. And then I can look at, well, what are all the disks that are available to me? And I see 8. I see all of the disks in all of the nodes. And now what I'm going to do is I'm going to create a storage pool. I'm going to say, well, use that. I'm going to use mirrored resiliency, fixed. This is now going to go and create me a new storage pool using those 8 disks across all of those nodes. Next thing I'm going to do is create a ReFS volume using that new storage pool I just created. Just creating the volume. It's going to format it quickly. And then just to kind of prove, I mean, British, people tend not to trust the British. So I could say it's using all the disks and local nodes, but you know what, we're a bit shifty. So I want to try and prove that point. And the way I'm going to prove it is what I have over here is I have a performance view. So I can see that I'm using physical disk bytes on each of the 2 disks in each of the 4 nodes. So what I'm going to do to prove this is I'm going to use a performance tool, disk PD, and I'm going to run it against that cluster shared volume I just created. It's going to be volume 1. So when I run this command, it's going to hit that file. I can see each disk in all of the nodes taking the performance from that. So it's a single CSV. I created a single file. But as you can see here, it's actually distributing the I/O across all of those drives. So it's doing mirroring, so the data is resilient across nodes, across disks. But I'm just using local storage. Now, if you have a SAN already, fantastic. The cheapest storage is the stuff you already own. But as you look to the future, as maybe you have branch offices, other environments, I'm looking at other ways I can handle my storage, hyperconverged really is the direction a lot of things are going. So you just have choice. I mean, that's what all of this is about. You choose what works best for you in your environment. So the other one is storage replica. There are a number of different replication technologies available. Obviously, there's things like DFSR. DFSR is great, but it only works for closed files. There's technologies in SQL, for example, and it's always great to use an application-level replication if you can. What Storage Replica gives us is a block-level replication technology. It sits underneath everything else. It doesn't care about the file system. It doesn't care if BitLocker's there. It doesn't care if a file is locked. It's going to synchronize at a block level. And it can do synchronous or asynchronous. So if I'm within a very low latency environment, within a data center, great, I'll do synchronous replication. If it's between locations, then it will do an asynchronous replication. And again, it's using SMB3. Everything is built on SMB3 today. I can take advantage of all the engineering work the SMB3 team have done. This can work between clusters. It can work within a cluster. So I could actually have Storage Replica replicating to different storage spaces direct in 2 different locations. And if I fail over services, it would flip over that replicated data to the other side and the VMs and services running on that data. So these things actually work very, very well together. And it's just, again, it's in box, part of the data center SKU. Networking. I can kind of see, my eyes have adjusted a little bit. Who's using network virtualization today? OK, there's a couple of people who don't want to put their hands up. Not many people use it today. I think 2012 and 2012 R2, they had kind of a good stab at it, but it was hard to set up, it was hard to manage, and there were limitations to what it could interoperate with. So in Windows Server 2016, they've really completely revamped the network virtualization. It's called Software-Defined Networking v2. And you're going to hear the word Azure inspired a lot. Sometimes it's just totally took Azure behind a corner and beat it up and took its code. Sometimes they just kind of copied what they did. But if you understand Azure networking, you understand SDN v2. And that's necessary. If you look at things like Azure Stack, which is going to bring Azure on premises, you have to have a consistent networking stack. And so with SDN v2, there's a whole new set of components to light up this functionality. There's now a network controller. So if you ever did use network virtualization in 2012, if you think about this kind of a data plane, a control plane, and a management plane. And really the control plane was SCVMM. The management plane was SCVMM. In SDN v2, the control plane is this network controller component. It is the brains of everything. It has a northbound API, i.e. going upwards to talk to management tools. Then it has a southbound API to actually go and talk to the resources that are taking part in that network virtualization. It could be Hyper-V host, hosting VMs. It could be software load balancers. It could be gateways. But this is really now the brains of it. There are other capabilities built in. There's a multi-tenant gateway. There's a software load balancer, again, really taking the Azure model. You have these separate components called a MUX that takes the incoming request, and then it offsets the actual NAT and all the other operations off to the VM switch itself. So it gets very, very great efficiency. But I don't require SCVMM. That's one of the choices. I have three choices. One is SCVMM. One is PowerShell. There's actually something called SDN Express. It's something I can download. And if I run SDN Express, it will just automatically set up all of the components I need. Network controllers, gateways, MUXes, everything I need to do network virtualization v2. Then, of course, Azure Stack. Azure Stack actually uses SDN Express. I have to pick one and kind of be loyal to it. I can't create the network virtualization environment with SDN Express and PowerShell and then try and manage it with VMM. VMM has no refresher. It will not detect that there is a virtual network. Likewise, I can't really go and deploy it with SCVMM and then try and manage it with PowerShell. VMM will not detect the changes I've made. So I have to pick a direction, and I have to stick with it. That may change in the future, but for right now, that's really where it is. Broad software-defined networking support. Now, what this means is in the past, it was NVGRE. They've actually expanded this out. So now it's actually VXLAN as well. So you have the option of using NVGRE, or I can actually use VXLAN. And VXLAN is actually the default. And VXLAN is much more of an industry standard. And so it's going to work with a lot of other tools, other stacks. Now, what's interesting about this, a lot of people look at network virtualization, and they really are just like, I like VLANs. I don't care the fact that I have to go and add a new VLAN and update 4 different switches at 3 different levels. I understand VLANs. I'm comfortable with VLANs. Why would I do this thing? And there are a lot of reasons. I mean, I don't have to mess around with physical switches anymore. It's all done in software. I'm not limited to a certain number of VLANs. But from a security perspective, it can actually really help. If I think about regular security with virtual machines, I have a virtual machine, I have certain services and data, and the VM can have a firewall. So there's a certain level of protection just in the virtual machine itself. We always want to do kind of defense in-depth layers. I have a physical network. And on the physical network, I have denial of service protection. I have appliances on the perimeter of my network. I have firewalls. I have access control lists. Again, trying to add layers of protection. But that's really it. Once someone gets through that wall, the ability to laterally attack is very easy. I can move very simply between different environments. If I add in network virtualization, I get a bunch of extra layers. By default, each virtual network is isolated from every other virtual network. There's something called a data center firewall. This uses kind of network security groups rules. So even within a virtual network, I can say, well, this virtual subnet can only talk to this virtual subnet. This virtual subnet can only do this type of traffic to these ones. So I can restrict it even further, all using the software-defined rules. I can put in virtual appliances. So I can actually add in virtual machines from major vendors. And think about this. This is going to be consistent with Azure. Azure runs Hyper-V. Azure has a certain networking stack that has been taken for Windows Server 2016. So if there is an appliance in Azure, you can bet it's going to be coming to Hyper-V 2016 very, very soon if it's not there already. So I can really add additional layers of security to my environment. OK, clustering. Clustering just keeps going through these really cool new features every single version. But one of the things clustering has suffered from was an assumption. And the assumption was people were experts in setting up clusters. Because in the old days, I had to be. Setting up a cluster back in the 2003 days was a 50 dialog screen. It required my DNA. It was a nightmare to try and troubleshoot. I had to have cluster-specific hardware. Well, they made it a lot simpler. 2008, 2012, much, much simpler. It's now 2 dialogues. I just type in a name, and I'm done. But the problem with that is, so we get these clusters that maybe aren't as well architected as they should have been. The network's a little bit shaky. The storage, not quite as good as I wanted it to be. And what happens is, you get these transitory problems. Hey, the network blips for a second. Just 100 milliseconds, blip in the network. But that blip in the network made this one node drop out the cluster. Well, when it drops out the cluster, all the virtual machines move to other nodes. They have to restart. So I have a 10-minute outage for a 100 millisecond network blip. Same on the storage. Hey, the storage had a blip. 100 millisecond blip in the storage. All the VMs crash. They all blue screen because they lost their storage. They can't handle that, so they crash. And so Windows Server 2016 has taken a big step to actually try and protect against those transitory problems. And I'm actually going to show that in a second. Domain boundaries have gone. This is going to be exciting for SQL people. So in the past, there were steps taken to remove the requirement to create AD objects, but it was still had to be part of a domain. In Windows Server 2016, I can have some nodes in a domain, some nodes in a work group. It doesn't use Kerberos anymore for the authentication. It uses certificates. So when I create a cluster, it automatically creates certificates that it uses for the authentication. So domain boundaries are gone. They can be in different domains, no domains, any combination. It doesn't matter. It's easier to get there. I can now mix clusters. I can have 2012 R2 and 2016 nodes in the same cluster. So when I'm on 2012 R2 today, and I want to get to 2016, I drop a node out the cluster, I reinstall it with 2016, and I put it back into the cluster. I take the next node, drop it out, reinstall it with 2016, put it back in. I just rinse and repeat until all the nodes are running 2016. The 2016 boxes are pretending they're 2012 R2 at this point. They're just running in a sort of emulated, hey, I'm in a 2012 R2 functional level. Once every box has been upgraded to 2016, I flip a switch, and now it's going to run in 2016 mode. I'm going to light up the new 2016 features. So it's going to make it much easier for me to now get between different versions of Windows Server. I don't need a whole new set of spare hardware. I don't have these hideous migration things that we kind of had to do in the past. Clustering has gone to the cloud. I can now use an Azure storage account as the witness. So in the past, I had a disk witness or I had a file share witness. But if I had a multi-site cluster, it was always challenging. Well, where do I put the witness? I don't want to put it in either site. I want it in a third location. I don't have a third location. Well, now an Azure storage account could be the third location. If I'm creating clusters in Azure, that's an easy way to create the witness. And it's super simple. When I configure the witness, I just say, hey, I want to use an Azure storage account. Here's the storage account key. It doesn't keep that key. It actually creates a shared access signature, which is what it uses for the ongoing access. Now, you might wonder, well, wait, Azure is consumption-based. So I'm going to have to pay for this thing. And yes, you will. But let's have a quick look at actually what it's likely to cost me. So if I look at my storage account, it creates a container called Microsoft Cloud Witness. And I have 2 different clusters using this storage account. And what it creates is one file. And once this actually refreshes, what you'll see is it's a whopping 0 blocks. So Azure does charge based on consumption, but what it creates is a 0 block file. It's actually not 0. There is basically a number in that file, so it is a little bit bigger than a 0. Eventually, you may get charged a penny, but that will probably take some time. So this is effectively free. I don't know what this is doing. It probably would refresh at some time. Let's go back to the blobs. I'll let it go and refresh. I would like you to see the 0. There we go. There's Cloud Witness. I go into that container. 0 bytes. So there's one file for each cluster, and it's a 0-byte file. So it's effectively a free witness. You have to be careful with that. Again, it may cost you a penny at some point, but it's tiny, tiny, tiny. So now I can use Azure as a witness for my clusters, really for no extra cost. I get an additional location with no real spend there. So what is this compute and storage resiliency? And it's probably easier to just see this in action. The idea for this is if a node loses communication with the rest of the cluster, instead of falling out of the cluster and all of the VMs move to other nodes, I'm going to put it in an unmonitored state. I'm going to let it keep running the VMs. Because again, it's a bigger outage to move the VMs than to just say, well, I'm going to leave you unmonitored for a minute. If it loses access to storage, just pause the VM. Don't let it crash. As soon as I see the storage, the I/O is having a problem, pause the VM, and then recover from that. So if I jump over to my environment, and I've got a 3-node physical cluster. And what I have is, on the 3rd node, it's running 2 VMs, VM3 and VM4. Now, one thing you have to realize, though, is if I'm using cluster shared volumes, if the cluster node loses access to the cluster, CSV won't work anymore. So the storage will get interrupted. So VM3 uses a cluster shared volume. So I expect that to pause. VM4 actually uses a file share, a scale-out file server. So I'd expect this one to carry on because it can still get to its storage. So what I want to do is kill off the cluster service. And what we should see is VM4 will keep running. It's unmonitored, but it will keep running. VM3 should pause. So I jump over to that 3rd node, and I'm going to end its cluster service. And I see VM4 has carried on running. VM3 has gone into pause critical. The node has gone into an isolated state. And if I scroll down, the VMs are now unmonitored. Now, within about 30 seconds, the cluster service will restart. It will re-communicate, and it will just come out of those states. But now I have that resiliency. Now when I think about those transitory problems, they're not going to bring me down anymore. It's going to do the best it can to protect you from that. Hey, I've lost access to my storage. I'm going to pause your VM for a little bit. When I get the storage back, sure, I'll resume it. Hey, I can't talk to each other anymore. I'm just going to keep running. I'm going to keep going for a little bit longer, and then resume as I have to. It also has a timeout. It has a corner of the room where it puts the bad servers. If a node keeps falling in and out of the cluster, if it happens 3 times within an hour, it puts it in quarantine. It basically moves all of the resources in a seamless manner to other nodes, and it says you can't do anything for 2 hours. The idea is in that 2 hours, it has a long, hard think about what it's done, and it doesn't do that anymore. The idea is the engineer has gone and looked at that node, and it does something to fix it. But that's just going to happen now. It's going to put them in quarantine. And there's that pause critical. OK, Hyper-V. Huge number of new features. New scale. 16 terabyte VMs with 240 virtual CPUs. I do not have a box I could demo that on, and I likely never will. But now I can really create these massive virtual machines. Nested virtualization. This was really lit up for containers. Think about containers. Remember I had that Hyper-V container option? Well, that's running a VM. Well, if my container host is a VM, I need to be able to run a VM on a VM. So that's why nested virtualization was added. That was the key driver behind nested virtualization. So I could do Hyper-V containers on a virtualized container host. But it's not restricted to that. I can use this anywhere I want. And really all this does is a switch. You have to enable it on the virtual machine, and it passes through the hardware-assisted virtualization capabilities of the processor into the virtual machine. Now, one level of nesting is supported, but I'll be honest, I've played around with it, and there doesn't seem to be an actual limit. But that's kind of the supported one layer of nesting. This is great for lab environments. Now I can test new types of environment and scenarios even on a single piece of equipment. There is a new Hyper-V binary format. So the old XML-based files have gone. It's now a binary configuration file. This was really for a couple of reasons. One is people tended to go and open up the XML and change things and break it. But the other was it just wasn't very resilient to unplanned failures. If it was being written to, and then there was a power failure or a storage failure, it would corrupt the configuration file. This new binary format is resilient to that. So it's far more resilient to any kind of unplanned outage. Production checkpoints. So we've all been told from a very young age, do not do checkpoints in production. Very, very bad. Never restore them. Active Directory gets very upset. Bubbles of replication. Now what we're saying is, well, do you know what? We've created something called production checkpoints. Now this is an option I configure as part of the virtual machine. If I go and look at a VM, and I look at checkpoints, I have two options. I have production checkpoints or standard checkpoints. Standard checkpoints is what we're used to. This is where it creates a differencing disk. It's where it saves the content of the memory, the resource state, and if I restore the checkpoint, it just restores all that back. It wasn't aware a checkpoint was taken, and that's what we should not use in production. But now we have production checkpoints. Production checkpoints work differently. When I take a production checkpoint, it actually calls the VSS infrastructure inside the virtual machine like a backup, tells it to flush everything out to disk, and then takes the checkpoint of the storage. It doesn't need to capture the memory anymore or the processor state because it's app consistent. When I restore a production checkpoint, it restarts the VM from that state. Backups actually use production checkpoints now. In 2016, when I take a backup, behind the scenes, it's doing a production checkpoint. So now you have these options. I can actually use a checkpoint in my production environment. I can do a hot add, remove of memory. So this is not dynamic memory. So dynamic memory, you probably know, it's the process that looks at the working set and actually injects or removes memory from the virtual machine. But that was dynamic. I didn't really have control over that. And if I'm a hoster, if I need to maybe build based on memory utilization, that's not a great scenario for me. So now with this, it has to be Windows 10 or Windows Server 2016 guest, but it can actually add memory into the virtual machine, so it will see additional memory. But unlike dynamic memory, it will actually remove memory, and the guest will actually see memory has been removed. So it will actually say, hey, I'm going from 12 to 8. The VM would have to move stuff out of those areas and give it up. NICs. I can hot add and remove NICs to Generation 2 VMs. This could be Linux or Windows. In fact, even the hot add of memory works on Linux. I've seen some of the newer Linux distributions work with the hot add of memory, but the remove does not work. So I can add to Linux, I cannot remove from it. PowerShell Direct. Everyone loves PowerShell. What if I've got networking problems? We might use VM Connect to get a console up to a virtual machine. What PowerShell Direct does is if I'm on the host itself, I'm on the Hyper-V host, I can run PowerShell commands into the virtual machine. Now, I still get prompted for credentials. This is not bypassing security. It's not a backdoor into the virtual machine. But I'm on the host. I'm not using the networking stack. I can inject PowerShell into a VM, providing I'm on the host itself. So if I've lost networking, if I need to fix things, I can now run PowerShell directly into it. Linux now supports Secure Boot. I get a virtual TPM for Generation 2 virtual machines, which opens up something interesting I'll talk about in a second. Hyper-V Manager. I can now do backwards compatibility. I can manage older versions. I can specify different types of credential. Integration components are updated via Windows Update. And discrete device assignment. So this is kind of a new capability. I just want to demonstrate this super quickly. So who's heard of SOIOV? I can kind of see. So a few people. So SOIOV was the ability to map virtual functions from physical network cards directly into virtual machines. It gave me sort of the highest performing network capabilities. What discrete device assignment does is enables me to now map PCI Express devices directly into a virtual machine. Now, this is aimed at two scenarios: NVMe storage devices and GPUs. You may have heard announcements about the new N-Series Azure virtual machine where I have CUDA cards in my VM in Azure. That's using discrete device assignment. It's mapping a CUDA card directly into a virtual machine. So what I have in this box is I actually have, if I look at Device Manager, you see I have an I/O memory SX350 device. So this is a VM, but I'm directly seeing a PCI Express device in the box. Now, I cannot share that device. I have to have the driver running in this virtual machine. But if I need the sort of highest possible levels of performance, if I want those CUDA GPUs available to my VMs, I can now do that with discrete device assignment. I can map a PCI Express device straight into a virtual machine. Not even the host can see it anymore. It's now exclusively used by this particular virtual machine. Shielded VMs. Now, I imagine there's a lot of administrators in the room, and you're all honest, hardworking, good people. But some people not in this room are not. Some companies don't completely trust their administrators. They don't trust the backup admin. They don't trust the network admin. They don't trust the virtualization admin or the domain admin. And in reality, we could never protect from Fabric admins. If I'm a Fabric admin, I can get the VHD file, I can take it home, and do stuff to it. So what Shielded VMs does is it actually uses a health attestation. It can be a TPM2 in the physical host or Active Directory. We want TPM2 if possible. All AD attestation does is says, yes, this host is in an AD group. I'm not getting any guarantees that it's not had malware put on it. I've not got guarantees that someone's not put some unscrupulous code on it. Whereas the TPM attestation uses code integrity policies. It guarantees there's nothing running on it that shouldn't be there. There's nothing was loaded in at boot time. I get the highest level of attestation that this Hyper-V host has not been messed with. And what happens is the Hyper-V host requests a key from a separate host guardian service that says, hey, I want to start this virtual machine. Can you give me the key? That key doesn't even go to that host operating system in a normal way. You might have heard of virtualization-based security, credential guard. It goes into this lockbox that uses hardware virtualization technologies to lock it away from even the kernel. It then unlocks the virtual TPM of the VM, which lets BitLocker start, and I get access to it. So what does this give me? This is giving me BitLocker encrypted disks. So if that unscrupulous administrator takes the VHD file, big deal. They can't do anything with it. It's encrypted. They can't run a brute force attack against it. They can't get anything from it. Live migration traffic is encrypted. There's hardened VM worker processes. The only real usability difference is anything that directly accesses it will not work. So here I've got a shielded VM. Ordinarily, I could just double-click and access the console. If I try it with a shielded virtual machine, it says you can't, it's shielded. So I can't get to it that way. PowerShell Direct will not work. Certain types of, different types of serial connectors will not be available. So anything that could be seen as some type of way to get to it is blocked with a shielded VM. Fundamentally, what this is giving us, is the ability to protect from the administrator. That's its key goal. Now, if all I need to be able to do is encryption for certain regulatory purposes, then I can do AD attestation. I just want to encrypt the thing, fine. But if I really need to prove that I have protection, and a lot of governments and other types of facility are requiring this, I can now show I'm protecting this even from administrators. I can protect that environment. Remote desktop services. Finally, OpenGL and OpenCL support for RemoteFX. So RemoteFX lets me take a GPU and share it between multiple virtual machines. And in the past, it was only DirectX. Well, now it actually works with OpenGL and OpenCL as well. So if I jump over to my Windows box, and it's locked, I used to show sort of a DirectX game or something to demo this. Now we have a donut. So if I run a GPU test, what this will do is this is an OpenGL test application. If I run the stress test, that's all OpenGL. A better test would obviously be Minecraft. Minecraft is a Java game. It's using OpenGL. And what I have here, if I jump in, so notice it's running there. I'll select my world. It's building. And there. So this is all OpenGL. And again, this is actually on a server running in Dallas. So there's some latency between these things. And I actually feel bad that I took that picture of my son. He built this for me. So if I hit this switch, it does a little light up of the Microsoft logo. There you go. He's into Minecraft. So now, again, it's not really designed so I can play Minecraft in my virtual GPU environment. There's certainly a benefit to it, but I don't think that was the key design goal. A lot of AutoCAD applications, all of those things, well, they used OpenGL. They didn't use DirectX. But now I can do that. And remember that discrete device assignment. So I have a choice. I can use RemoteFX. RemoteFX, I'm sharing a GPU, so I get great scale. I get OpenGL, OpenCL, DirectX 11. Or I could use discrete device assignment. I could map a GPU directly to a VM. Now, I can't share it, but then I'm using the native drivers of that graphical hardware. I could do DirectX 12. I'm going to get higher levels of performance, but I don't scale as well. So you have a choice. And that's really now kind of a big deal around this. I can finally run RemoteFX actually as a guest for RemoteFX. So 2016 has kind of been boosted up. Instead of just having to be Windows 10 client, I can actually now use Windows Server 2016, and that will still get that RemoteFX. I can do larger amounts of dedicated memory per virtual machine. I can use Generation 2. I have personal session desktops. So what is this? Normally in a VDI environment, we run a client operating system, Windows 10. And when I create a VDI environment, I install something called the virtualization host on the physical hardware, on the Hyper-V host. And that's what lets me start the VMs, stop the VMs, get me pieces of information. Personal session desktops is kind of like VDI, but it's using Windows Server as the guest operating system. Now, why that's useful is each of those virtual machines, those Windows Server, is running RDSH, and I assign it to a particular user. So this is personal. A user is assigned a particular RDSH instance. So I'm not using Windows Client, so I don't have any Windows Client licensing challenges. There is no agent required on the Hyper-V host. So this is very useful in like a public cloud scenario. I want to give people a virtualized environment. Maybe I can't use client, or maybe I can't deploy things to the actual cloud fabric. Personal session desktops. I create the RDSH hosts in advance, and then I simply assign, well, John gets that one, Bob gets that one, etc. They still see it in RD Web Access. They click it, and they get connected through. Multipoint really used to be focused around education. The idea where I could have a single piece of hardware, and I would map multiple keyboards, mice, and monitors to it. It's now just part of Windows Server 2016. It's not a separate SKU that I have to go and buy. It's just built in for easy access. Pen remoting support. Instead of the pen acting like a mouse, the pen acts as a pen. The features of the pen are available to my remote sessions. And remote credential guard. So what is this thing? The idea here is all about protecting credentials. I want to minimize any exposure my credentials have. And so the way this actually works here is, let me pull up my demo environment again. It never sends my credential to the remote box. So normally, if I was going to connect to a remote box, I would use MSTSC and let's say the name of my server. It's going to prompt me for a credential. It's connecting through, and then that credential would actually be stored on that remote box. If I disconnected, if there was some kind of attack, maybe people get to that. What I now have the option to do I connect to the same box. But if I add remote guard, I'm just connected. So I get single sign-on, but the bigger point is my credential is not on that server. If there was some bad piece of code on there, if I disconnected, it can't get my credential. It stayed on my local machine. There's a whole new set of protocols that go on that even from that remote session, if I try to access another resource, it passes all those requests and ticket requirements back to my machine. I encrypt it with a special token, and then gets sent through. So this is another way to help protect my credentials from kind of bad actors. PowerShell. I mean, PowerShell is everything. If you look at the sort of progression of PowerShell, it gone through these very basic commandlets in the beginning to remote support, to covering everything, desired state configuration, and now DevOps. Now it integrates with things like OneGet. There's a package manager. It has native compression and temporary, all these new commandlets available to me. And this really just goes on and on to show this kind of commitment. This is the future. If I was going to pick one thing to learn, I always say PowerShell. People say, what should I focus on? It's PowerShell. And there were some neat little usability things. Let's jump over to a box for a second. So let's open up a PowerShell window. So the color coding now applies. So if I say name, VM worker process, you notice it's color coding the various parts of the command. If I resize my window as I'm doing stuff, actually let's get a bit more text over here. If I resize the window, it dynamically adjusts to wrap. But I think the real killer feature, if you weren't sure if you wanted to migrate to Windows Server 2016 yet, I think this will make you change. I can make it opaque. I mean, that's everything. I mean, I think, and that would apply to the command prompt as well. So now I can see what's going on behind my window. So just a nice little feature there, so I can still see if I'm doing various command work, I'm trying to keep an eye on what's going on, I can do that now. Active Directory. Nearly every environment I go to, there is a massive number of administrators. Over the course of time, everyone at some point has needed to do some administrative task. The CEO and his cat are domain admins in the environment. And it's very hard to get a grip on that. It's hard to fix that. And the whole goal of today is I don't want anyone to have standing privileges. I want just enough administration, so I only have the permissions I really need, and I want just-in-time administration. I get the permissions when I need them, and they're taken away from me. And that's now lit up in Windows Server 2016. So there's this new privileged identity management feature. It also integrates with MIM as a workflow engine. What this enables me to do is now I can have time-bound group memberships. So I can say, well, my user is not a member of domain admins. But when I need it, it adds me into a domain admin group for an hour. The Kerberos ticket I get that says I'm a member of domain admins is timed bombed to whatever the shortest interval of a group membership is. So if I'm only in domain admins for 1 hour, my ticket will only be good for 1 hour as well. So now I can actually use this, that I'm not a permanently domain admin, I'm going to get it when I really need it. And of course, don't forget about Azure AD join for sort of Windows 10 Corp devices. I want to go back to that PIM example. So this is what you have today. I have domain admins group at the top. I have organizational users with a ton of different people in. And I've lost all control. So the way privileged identity management works is I create a new Bastion forest. It's brand new, running 2016. And what happens here is I create a trust relationship. So I say, well, my old domain is going to trust the new one. In that new domain, I create new groups. Now, these new groups have the same SID as the group in the original domain. Now, normally SIDs are based on the domain, GUID, and a unique. These actually have the same SID. So this group over here that's empty on the right, this has the same SID as domain admins. This one has the same SID as this OU group. So I create these brand new groups. I then remove everyone from all these groups. Now, I probably leave one person or two key people in the domain admin role just in case something goes wrong and I have to fix this thing. But everyone else is removed. So now what happens is I'm a user, and I say, hey, I need to do something that requires a certain level of administrative permission. So I go through this workflow. That workflow will add me to that shadow group. Now, because it has this shadow principles type of object, it has the same SID, I'm added to it. I authenticate, and it's time-bombed. I'm in that group for an hour or 2 hours. So I authenticate, I get a ticket back. But remember, the ticket is time-bombed to the 1 or 2 hours as well. I want to access this resource over here. I use that ticket. It lets me access it because, effectively, it thinks I'm domain admin. It has the same SID. It has the same permissions. But once that group has expired, I lose that permission. So now that's just part of Windows Server 2016. I have the ability to really solve this. Now, for the workflow, you could create your own, or Microsoft Identity Manager is going to do that as well. But it's using that base capability in the operating system to light up that scenario. Security. This really is at the core of everything they've done in Windows Server 2016. We're in the world now where we just assume breach. They say there's 2 types of companies, those that have been breached and those that don't know it. So all of the technologies are really geared towards assuming that breach and how I can protect from it. Now, on the host operating system, remember those 2 personas, shielded virtual machines, host guardian service, VM security, code integrity policies that say what's allowed to run, credential guard to lock away credentials, containers, nano, all give me that protection. From a guest operating system, so this applies no matter what hypervisor, what host I'm on, control flow guard. Now, this has been explained to me a whole bunch of times. I still don't fully understand it. But it's the idea that I have a stack of instructions, and bad things can try and rearrange that stack and perform bad actions. Control flow guard stops that. It protects things messing with the stack. Device guard says only these processes can run, and it's going to use hardware-based security mechanisms like TPM to help enforce that, so I can't bypass that. Credential guard, remote credential guard, we talked about. Privileged identity management, just enough admin, just-in-time admin. Much better event logging now to actually show me exactly what has changed, who changed it. Built-in anti-malware with Windows Defender, and of course, Nano Server. All of these things help me create these very locked down, super low attack surface environments in both physical and kind of those guest scenarios. And that's my kind of top 10. Now, there's a whole bunch of other sessions going on. I don't have a slide to say, look at these other sessions, because every other session would apply. Each of them being given by someone far smarter than me about their particular area. So I highly recommend, if there's something I cover that you're interested in, go and attend one of those sessions. We have to tell you, please fill out an eval. Or what I'm told is for every person that doesn't do an eval, a puppy gets kicked. So if you like puppies, please do your eval. With that, I'll happily open up to Q&A. And if you can go to the mic if there's a question, or if everyone's leaving, I can just hang up at the front. So the question was, any improvements in group policies? There's no major changes to how it's handled for the group policy. Now, a big change, obviously, in Windows 10 is there's still group policy, but now obviously you have the whole sort of mobile management stack, which is common between mobile devices, all the different types of Windows device. So now there's group policy object, or there's mobile device management. There's kind of those 2 different options available. But base group policy is fairly static. I think there's microphones I just can't see. Yep.
Do you think that Nano Server is a good application for an IoT hub?
Say that again, please. Sorry.
Do you think Nano Server would be a good application for an IoT hub?
So I'm not a big IoT person. My understanding is the IoT is obviously a separate version of Windows really designed around IoT. Nano Server today, if the application will run on Nano Server, because Nano Server has a refactored kind of version of PowerShell, has a refactored version of .NET. But if I can make an application run on Nano, use Nano. If I can't make it run on Nano, use Server Core. If I can't make it run on Server Core, try again. So I really don't want to use desktop experience.
So what's the licensing restriction on Nano servers?
Nano Server is still just Windows Server. It's kind of the same SKUs that standard. It's just a different deployment mode.
Is it part of Server 2012 licensing or Server 2016 licensing, or is it?
Yes, a Nano Server is still licensed like a regular Windows Server 2016. It's just a different deployment mode. It's like I buy Windows Server 2016 standard or data center. I could deploy desktop with experience. I could deploy Server Core. I could deploy Nano Server. It's the same. It's still a license of Windows Server.
Thank you.
Cool. So the question is, what type of trust is required? So it's actually a new type of trust. Well, that's a lie. There's a new type of principle has to be accepted by the trust relationship because it has to support these shadow security principles. It's kind of like an enhanced SID filtering. So there's going to be an update for 2012 R2 for sure to understand that new type of trust relationship. But yes, it will require an update because it's not going to understand why is this SID coming to me that's the same SID as my domain. So there's going to be an update to the type of trust. I need to double check exactly, is it only 2012? I think it is 2012 R2 and 2012. I don't know if it's going back beyond that to support it. Question. So the question is for the shielded VMs, can I add? Yeah, I can still add and remove resources from it. I just can't do anything that's kind of like a backdoor. I can't use the VM Connect. I can't use PowerShell Direct. But I can still manage it just like a regular VM. Yep, I can add more RAM. I can add more CPUs. Yeah, exactly. Sorry? Oh. OK, Nano Server requires software assurance. Yeah, it's still a license, though. I still need a Windows Server license to use it. Yep. Question? So the question is, Hyper-V resiliency, how do you handle split brain? So the network controller is really the brain of network virtualization. And it uses something called Service Fabric. So Service Fabric, again, comes from Azure. So the idea with Service Fabric is I have multiple instances of the network controller, and they all synchronously replicate their state. Oh, so you're not talking about networking, you're talking about, OK. So just regular clustering. So it only does that for a certain amount of time. So all the other nodes will give it, let's say, 4 minutes to talk to them again. After 4 minutes, then it's like, OK, it has to shut the VMs and then it would take them over. So you can change that interval. Obviously, the longer I wait, the greater the chance that it really is not available and my VMs are not running anywhere. So 4 minutes seemed like a good value to say, hey, we'll give it 4 minutes to cure any network problems and come back. But after 4 minutes, the node running them will drop them, and they will be taken over by other nodes. But you can tweak that. If 4 minutes is too long, I can tweak that. Cool. I'm completely lost.
Can you talk a bit about the difference between Hyper-V's dynamic RAM versus hot remove RAM? Like, if you already have dynamic RAM on Hyper-V, what's the benefit of the hot add?
Is the question what's the difference between dynamic memory and hot add remove of memory? So the way dynamic memory works is I set a starting amount, a minimum amount, and a maximum amount. And what the Hyper-V host does is it looks at the working set, i.e. the amount actually being used by the VM. And if it's available, we'll dynamically add more in or take memory away. But it's completely fluid. You don't really have a good control over that. With hot add, the VM has a static amount of RAM. That's what it gets. Then I, as an administrator, can choose, I'm going to add 2 gigabytes to it. Or I want to remove 4 gigabytes from it. So it just gives me far more control over the resource use. And again, where that's really useful is think of a hoster. Hosters don't really want to just inject dynamic memory in and out of a virtual machine. It's very hard for them to bill and track that. Whereas if I can statically add 2 gigs and then remove, that's a far better scenario for me in terms of management.
Got it. All right.
That make,
Thanks.
cool. Yeah, so the question was, in 2012, we had different configuration levels. There was desktop with experience, there was sort of server with a GUI, there was no shell, but I had management tools, and there was server core, and I could change those. In 2016, I cannot do that. In 2016, what I installed is what I'm keep forever. So in 2016, I install Server Core or I install Server with desktop experience. There is no option to have a GUI without desktop experience. There is no option to have management tools without the shell. The idea is nothing should really be running the GUI anymore. It's for remote desktop session hosts. Everything else should be running on Server Core or Nano. Maybe in a future version of Windows Server, it'll be Server with desktop experience and wolves gnawing at your legs. They want you to get off of it. The goal is Nano Server and Server Core. Yeah, so the comment was it's obviously great in the future. I could build it with a GUI and then remove it. Again, the future direction for this really now is everything's automated. So in that cattle world, I have scripts and things that deploy and create the virtual machines or the physical hosts. I'm not manually setting that stuff up because I can't automate that. I'm at time, so what I'm going to do is I'll move outside, or Andrew will start beating me up, and I'll take you out there.